I'll just remind you, those who haven't been here before, what this is. So this is a series of conversations dedicated to the question of public communication of climate change and to the forms of public communication of climate change that we organize at the Maison Française d'Oxford in the context of a larger series of events dedicated to the topic of science and the public sphere. And this is the third conversation that we have this year. So before I present our speaker, I'll just a couple of housekeeping issues. When we get, I would want to make sure that when we get to the end of the conversation, which should be in about 45 minutes, we should have at least 15 minutes to discuss. And the way that we will do that is that if you have a question to ask, please do not raise your hand because then I can't keep track of who asked questions first. Just send the letter Q in the chat. Don't ask your question in the chat. Just send me the letter Q in the chat so that I know who asked the question, and then I'll get to you when it is your turn. So, okay. So I think that was all for the housekeeping, and then I will get on and I will present our speaker. So, as you all know, our speaker today is Sarah Dry, and Sarah Dry on her website presents herself as someone who writes about the history of the science. And she's currently a research associate at the project called Making Climate Science at the University of Cambridge. But long before that, actually over the last 20 years, she's written extensively on a bunch of central figures in the history of science, from her first book of Marie Curie, which was published in 2003, entitled simply Curie, and the Newton papers, which is sort of a plunge into Isaac Newton's unpublished manuscripts, which came out with Oxford University Press in 2014. And then I should also perhaps mention here, we just talked about it before I opened up the meeting, an edited volume she did in 2010, entitled Epidemics, Science, Governance and Social Justice, which was dedicated to global politics and emerging infectious diseases, which is a curious volume which proves once again that sometimes, if just sometimes, policymakers would actually listen to what scientists say and writers of science say, we might not be quite in such a mess today. Anyway, most recently, she published a book, which is the one we will focus on here, which is a book entitled Waters of the World, which is a book that came out with the University of Chicago Press in 2019. And then we will, I think Sarah will explain more herself in a minute what she's trying to do with that book. But I just want to mention how all these different books that she has written sort of testifies to her. She really has a unique knack of presenting original and profound research in a way that is approachable and sort of very readable, even for people who are not at all a specialist on the topic. So perhaps you can hear from what I'm saying, I'm already myself quite a fan. But enough about that. At this point, I will just give the word for 5 to 10 minutes to Sarah. I think so she can sort of explain a little bit about Waters of the World, and I think she also wanted to show us a couple of slides along the way. So Sarah, over to you.
Thanks so much, Mogens. That was a wonderful and generous introduction, apart from the shocking number of 20 years, which I thought surely couldn't be true when you said it, but then of course it is nearly true, that I've been thinking about and feeling passionate about history of science, which I suppose if I put it in those terms isn't such a bad thing. So I will talk a little, I thought I'd talk a little bit about what brought me to write Waters of the World. But before that, maybe just a little bit about my background, aside from the sort of publications, because I think it's relevant to the question of why I write the way I do, or why I write at all. So I studied history and literature in what we call college in America at Harvard, and was always interested, I guess, in that interdisciplinary trick of doing two things at once, or treating texts as both literary objects and windows into another world. So I guess that interest in literature and history was always with me. And my interest in science came a little later. I did journalism as well in college. Well, I mean, I was on the student newspaper and worked at some newspapers in the summer. Dallas Morning News. I was like an arts reviewer intern for them. And then I worked for an environmental newspaper called High Country News immediately after college. So always had an interest in, nature and the environment, as bland as that sounds when I put it that way. And then worked for a time as an assistant to a science editor at University of California, Berkeley. So starting to bring science and writing together. Then ended up at a biotech company as a communications person, sort of writing whatever needed to be written there. Again, interested in science from the outside. And then somehow came up with this brilliant idea to study history of science, which until that point hadn't really occurred to me. And ended up moving from San Diego to London to do that for what I thought was would be a year. That was going to be a master's degree. It turned out to be a master's degree at Imperial College, but it turned out also to be 20 years. So that's that 20-year start. And that started me on this wonderful journey with history of science as an academic discipline, which I really just completely fell in love with in a way that I hadn't with any previous intellectual enterprise. As studious and engaged as I'd been, history of science just kind of blew my mind, I think, because of the way that it combined a philosophical basis, understanding what makes knowledge work, with all of the contingencies of history, and then all the narrative forms that historians use. But I've always felt this pull back and forth between the academic and the more, I hesitate to say popular because I wish my books sold more, but oriented towards the people, writing that has more in common with the best parts of journalism or the best parts of books written for a general public. And so I've tried to do that in various ways with some of the books you mentioned, notably the book on Newton's papers, and then more recently this book on the history of global climate, which in a way emerged from my PhD, which was about science, governance, and risk in Victorian Britain. If I put it glibly, I say it was about shipwrecks and train wrecks. So it was about the origins of the Department of Meteorology and the Railway Department, and the ways that the government tried to use scientific knowledge and expertise to manage new risks. And that kind of set me up conceptually, both for thinking about epidemics and thinking about first, the origins of meteorology, but then naturally leading on to the great challenge that we face today, the challenge of climate change and all its accompanying entanglements. But I never left behind that interest in the literary. And so I thought I would start by admitting that Waters of the World, in a way, is the product of a failed novel, which is to say that I started writing a novel about a scientist who I'd spent a lot of time working on in my PhD, whose name is John Tindall, and spent quite a long time immersing myself in his diaries and letters and papers. And I thought I would just read a little bit of the beginning of that novel, and then compare it maybe with what ended up in the book, as a kind of way to set the stage for this conversation about how we communicate around history of science generally and what we might call history of climate science. So 1893. This is only about a page, don't worry, I'm not going to go on too long. Blue was the color of Louise's eyes. They were the color of slate, with a cool smoothness that hid an astonishing ability to fracture upon receiving a blow. The coroner was taking his time. This was a family matter. Procedure would be followed, but the professor's wife needed time to compose herself. Tindall lay on his bed, his head propped on a woolen blanket. The famous beard fell away from a thin mouth. Dr. Hutchinson sat with Louisa in the parlor, where no fires had been lit that day. It was very cold. Louisa explained what had happened. 2 bottles, ordinarily sat on the table by the bedside, a tablespoon and a half of sulfate of magnesia to be taken in the morning for dyspepsia, a teaspoon of chloral at night to ease him into sleep. But that morning, a third empty bottle of chloral had obscured the full chloral bottle sent from the chemists. Louisa had set aside the empty bottle and reached for its full sibling, thinking it to be the magnesia. She carefully measured, and Tindall swallowed a full dose. There was a curious taste, he noticed. Louisa also tasted sugar in the drop that remained in Tindall's glass. John, I have given you chloral. He understood immediately. My poor darling, you have killed your John. The hours passed quickly thereafter. Let us do all we can. Keep rousing me. Tickle my throat with a feather. Send for a stomach pump. Tindall was given hot water and mustard and made to vomit. Dr. Winstanley arrived. Hot water bottles were prepared and stacked against Tindall like berms. Hot coffee poured into his throat. You are all rousing me, he said as the electric battery jolted him. At 1 o'clock, he was partially conscious, but by 4, when Dr. Buzzard arrived from London, he was insensible. Louisa told the coroner, we worked all day. It was about 8:30 in the morning and about 6:30. It had all ended. So I just wanted to briefly share my screen now. Can you guys see that?
Yes.
So it may be slightly obscured by the Zoom images, but on the left is the newspaper article from which I took verbatim actually most of the dialogue in that piece, describing the death of John Tindall, who was in fact accidentally poisoned by his wife, Louisa. And then on the right, I've given the sort of page from the book in which I describe this incredibly dramatic scene, which which really inspired me to at least start to try and write this novel. And in the book I ended up writing, it ends up as sort of fairly bland description in this paragraph. Tindall died in the evening of December 4th, age 72. Louisa, just 47 at the time, never forgave herself. So I don't know if I'm doing any favors to the book I wrote by reading that, because I think I think they're very different ways of representing the same thing. I share it to just show you that this was an active question for me in grappling with the material. And I almost feel like one could write multiple genre forms based on the same material, and that it might be an interesting thing to actually do that. Although I have to say I haven't quite done that, in the sense that I never finished the book, the novel. I just wanted to show you, and then I'll stop talking. The book I ended up writing is about 6 scientists, and it takes each of them in turn and attempts, using biographical stories about them, to tell the story of a larger idea that I assert and try to demonstrate connects them, which is this idea of a global climate, which is something that I try to argue in the book was created out of a combination of very disparate contributions from people working in different disciplines, and that what we take to be climate science today is actually this kind of mongrel thing. And I try and in that way square the circle between doing biography and doing proper history of science, or big picture history of science, or any other kind of thing we might say. So I'll stop there, and I hope that's just given a little bit of an insight into the pathway that led me to this book.
Thank you so much, Sarah. I think it gives us a fairly good idea of. I mean, one thing is that as you read the book, you follow a progression of authors, a progression of scientists throughout the book, and I think it's important to also realize that the book itself is such a progression, as it were, and it's kind of fascinating to think about that the way that you came about to do this, which you do so very efficiently, is sort of the other way around. And I think most other people I know that work on writing this kind of material, they start out as scientists, or they start out as historians of science, very academically, and they start out, I mean, in my own discipline, they start out as historians of philosophy, and then they end up writing an easy to read biography of a great philosopher or whatever it might be. And it's kind of curious to know that you started out the other way around. You started with literature first, and then came back to, because it maybe gives you a better sense of the constraints that there is on your writing. When you write, so I don't know whether that's something you would like to say something about. I mean, when you move from novelistic writing as the first section that you read, and then you move over to writing the more sort of what you actually wrote, what kind of difference is there between, or what kind of constraints are there between the two of them, and what kind of considerations led you from doing one to doing the other, as it were? I mean, why did you choose to do what you did rather than the other one?
Well, the simple answer is that it's just really damn hard to write a novel, actually. Science is easy compared to writing a novel in many ways. And I think what interested me about the novel was never pure invention, but it was marrying very rich primary sources that were themselves quite novelistic in nature to some kind of narrative that when we're talking about a novel we call a plot. And that was an exciting challenge, but ultimately, in a way, I think I didn't have the courage to let the book be a little bit one of those books that's hard to define as fiction or nonfiction. I'm trying to remember, Ruth Skur wrote a biography based entirely on the words of an individual, and I can't remember who it was now. So it was basically a novel created out of fact. And I kind of think maybe if I did it again now, that's what I would do, and I wouldn't worry so much about creating a plot, as it were, an externally imposed plot. And I think that the book I ended up writing, because it has this kind of complicated structure of 6 individuals, I mean, that's not novelistic, but it's a complex structure to try and deal with. And maybe that was sort of the inheritance that I gave myself coming out of starting where I began. But I will say it happened very, organically is the nice word for it. The sort of more authentic word is, painfully. It happened iteratively and over a period of time. And there were different figures that I thought about including, which after investing a lot of time and effort in, realized that even though aspects of their lives were fascinating and indeed relevant, they didn't fit all together. And I will say that even now, I don't know about other people, but it's never easy to feel completely satisfied with the book that you've written. And, I think one of the things about writing a book about a group of people, in which each chapter sort of has to carry its own weight, is that you see the varying qualities of the chapters. And I think that I certainly have favorites among them. And that partly has to do with how I wrote them. And that's also partly to do with what sources were available and how much insight those sources could give me, which I guess.
It's clear, for example, when you write about John Tindall, you're quite emotional about that.
I'm close to him.
I'm very close to him. But I think there was one thing in what you said that I'm not quite sure I quite agree with. You say it's not novelistic. That depends on what kind of notion you have of a novel. I actually think it is very novelistic. And one of the things that I personally quite like, when it comes to fiction, or this you say, this middle category where you don't know whether it's fiction or whether it's science or whatever it is, I tend to be a little bit suspicious of those kind of publications, because very often what happens is that, let's say the non-fictional biographical becomes sort of a cover for writing mediocre fiction, and let's say the other way around. The imprecise historiography becomes sort of covered over by the excuse that I'm just writing fiction. This is what very often happens. I won't say that it can't be done, and it certainly has been done successfully in some instances to write that kind of stuff. But still, I think there's something about the stuff that you have written that is where there's some of the historiographical constraints that is put on, let's say that you have to, some sort of historiographical exactitude that you have to live up to, put some constraints on your narrative that actually gives it life in many ways, and prevents one from falling into easy traps, like writing just a story about a hero, for example, which often happens, sort of hagiographical stuff. That you end up with a narrative which is there's I don't know whether you know there's a famous, well, you probably know this famous theoretician of the novel, Mikhail Bakhtin. He had this notion of what is the construction of a novel, and he said it's heteroglossic. It's many voices going together at the same time. And one of the things that really struck me when I read Waters of the World is that it is a narrative that is heteroglossic in a very precise kind of way, namely in that you have these 6 figures that you follow, but you follow them in relation to each other, in relation to their opponents, in relation to the collaborators, in relation also, also very sensitive, very sensitive to the people who are sort of helping him. The research assistants and the people who were, carrying their stuff, and all these people around them, and this kind of collective narrative that historiography sort of imposes upon you to bring into play. I really think it's a very efficient way of communicating these things. So, so that was just sort of a comment on
well, thank you. Thank you for, I'll take heteroglossic. That's lovely. And I guess I owe that to my training. I've been, I had a good education in history of science. And at a certain moment in time, when it's very much the case that academic historians of science are at pains to show that science is a collective enterprise. Science is an enterprise in society, not apart from society, not separate from it. Science is as much about failure as it is about success. Discovery is retrospective, all of these things. So I think that's, we all carry voices in our heads of those we want to please. And I have some strong voices from my experiences in academic history of science that have given me that sense of, and I've internalized it, as it sounds like, of, precisely the kind of representation of science that I want to make. But the difference is, I guess, that as someone who wants to reach a larger audience, I recognize the merits and the value of focusing on individuals. And so it's this constant tension between giving an individual his or her due, allowing them to take center stage, while at the same time indicating all of the ways in which that person is connected to others, stumbles, doesn't succeed, is motivated by a variety of venal and less venal ambitions. So I just saw that someone in the chat said, who are these people? And I thought maybe I could answer that, because some of them, I should have given a more straightforward introduction to the book. So I might shall I do that now?
Yes, you can do that now. I was just about to do it, but I'll let you do it yourself.
Oh, do you want to?
No, I'd rather that you do it.
Okay, I'm just going to briefly go back to the
slide,
because I think it's quite helpful. So top left is our man John Tindall, who was an Anglo-Irish physicist and tremendous popularizer of science, who lectured at the Royal Institution and was a great mountaineer, alpine mountaineer. And you can sort of sense in that photograph his wiry and goat-like frame, which enabled him to clamber all over the Alps. And Tindall today is most well known for his work on the absorption of radiant heat by gases, which is now seen as a kind of key milestone in the discovery of global warming, kind of early elaboration of the greenhouse effect. But one of the things I tried to do in the book was to show that Tindall is so much more than that. And in fact, understanding him in that way is very much a presentist view, looking back at the past, the anthropogenic effects of climate change. Anthropogenic climate change was not something the Victorians imagined, but they did imagine very much, spent a long time imagining the causes of the ice ages and what it was that could cause ice to grow and move across the surface of the earth in the way that evidence recently uncovered suggested that it did, and Tindall did fascinating experiments on that. And I tried to, so that's Tindall. I'm going on about Tindall too much, but you can see I'm still somewhat obsessed. The next man is Charles Piazzi Smythe, who is more interesting in some ways as a failed scientist. He ended his life excommunicated, as it were, from the Royal Society, having been Astronomer Royal for Scotland, and really was a keen observer of astronomical and meteorological phenomena his whole life, and advocated, among other things, for a kind of little rain band spectroscope tool that would enable everyone to diagnose the skies at a glance. So he's this interesting figure advocating for the potential for individuals to have a global vision of climate, and that's why he interested me. Gilbert Walker, top right, was an English mathematician, senior wrangler at Trinity, Cambridge, sent to be Director General of Meteorology in India at the turn of the century, the 19th century, into the 20th, at a time of tremendous famine, which had been, one could say, caused, although that's a weighted term, by the failure of the monsoons. And so Walker's role was to try and use statistical analysis of weather records to understand relations between barometric highs and lows, and try and come up with a way to predict the monsoons, in which task he failed, interestingly. Joanne Simpson, bottom left, very interesting first woman to receive a PhD in meteorology in the US, and did fascinating studies of cloud and hurricane formation, and worked on projects that tried to seed clouds and then hurricanes using funding and, as we see, material, as in instrumented aircraft provided by the US Navy. So she's a really good example of how individual scientists had to be very good at gaining access to expensive equipment if they wanted to do their research. And I try and push back a little bit against Cold War stories that frame these scientists solely in terms of Cold War preoccupations, although I recognize that some people have strong feelings about that in the other direction. Henry Stummel in the middle on the bottom he's often called the grandfather, the father of physical oceanography. So applying mathematical physics to the question of ocean circulation. Fascinating. As we see him here, he was a kind of pen and paper man who lamented the rise of big science, which in some ways his scientific contributions helped to bring about in oceanography. So there's a kind of wonderful, like, tragic quality to his story in some ways, although his life was very full and productive. And then finally, Willy Dansgaard on the right was a Danish geophysicist who kind of invented and perfected this technique for dating ice cores, which is just a fascinating bit of science, which also revealed the history of the planet as kept in what he called frozen annals. So that's that. I'll stop sharing now, and I hope I've piqued people's interest anyway.
Yeah. Thank you very much, Sarah. All these guys are absolutely fascinating. There was one thing I had a sense when you read the last chapter on Willy Dansgaard, which I had a particular interest in because I just happened to be Danish, and I was reading about these ice cores, and it was like you were telling a history or writing a history about how these cores, it was like the whole human history was lodged in these cores or carrots of ice. And at the same time, I was reading articles about how it had begun to rain, and it now begins to rain more on the North Pole than it snows. And of course, it erodes this whole thing. And it's a bit like you have the feeling it's not just that that is the planet and we are destroying it. It's actually also the history of the planet, the whole trace of the whole history of the planet that's melting away up there now. It was just sort of a double sadness. Yeah. Well, anyway, but just to come back to the history writing. So you write this book about these 6 people about how we get to have this idea of a global climate. That climate is something that is a global thing, which is quite fascinating because it's like you would think that was something that had been around forever, but of course it is not. And we learn how it does come about through these six people. Now, there are a bunch of ways in which that you write this story that I was quite struck by, and I think the first thing I was very curious about was that when you write the story of these six people, is that you don't want to, one of the things that you want to sort of oppose, at least in the introduction of the book, is you said you oppose this idea of a milestone approach, as you called it. And then on the other hand, you have what you call a singular history of a heterogeneous science, and which you then connect to this idea from Martin Roderick that history of science writing is a little bit like biblical philology. It's about or biblical history. It's about writing human and contingent history. So I think this is of course part of your history of science training, sort of something that's probably in your bones. But maybe I was kind of curious if you could just say a little bit about those things. I mean, how you see this story as a story about not so much about the science, but about and how you see this as a human story and as a contingent story, and how that differs, from other kinds of scientific accounts that you could imagine.
Well, I guess we're always fighting against teleology in history of science, the idea that science keeps getting better and better and we know more and more. Not because there isn't an element of truth to that, but because it doesn't explain how things happen in the moment, right? We try and adopt a kind of symmetrical principle towards actors in the past that we don't want to bring our present beliefs and assumptions to bear on the understanding of the past because it impedes us in that way. So I guess that was something I was keeping in mind as I was writing this. And that meant I was also thinking about the histories that climate scientists tell, because climate scientists do a lot of history. As you've already indicated, they, and as I think did as well, I mean, the study of climate is the study of the Earth's past. So the content of climate science is itself historical. Not all of it, but much of it. But also climate scientists, like all scientists, are very keen to tell a particular version of their own disciplinary past for various reasons. I mean, it's a part of the training of scientists to learn these histories. And indeed, that's the history of science that that's what most people think is history of science, what I kind of call milestone science.
Yeah. Is that the sort of thing that you speak about when you speak about the epistemic identity of scientists, how they situate themselves in relation to the science that they make themselves, or is that something else?
I'm not sure actually I'm not sure what you're referring to there, but I think I am interested in the ways that climate scientists purport and do speak historically. And that they're, I mean, if we want to talk about epistemology, their epistemology is partly one of historicity. So they have different tools for talking about history, however. And that's one of the things that I kind of discovered in writing this book and got interested in, is that, you have physicists who have a kind of dateless version of history that one might run, forwards and backwards. And then you have paleoclimatologists who are much more chronological in creating, timelines, as it were. And one of the interesting things about climate science is that it brings those things together in ways that have now come to seem natural or have become less visible. And it sort of literally like fixes them together in these charts where we see past temperature records and projected future temperature records, which are based on very different attitudes and techniques for understanding time and change dynamics. So part of what I was trying to do is show that, that climate science is made up of these different disciplines which have different epistemological approaches and different traditions, different genealogies. And so I tried in my biographical way to include people from very distinct disciplines. The reason it's called Waters of the World, even though it's really about global climate, is because the conceit is that each of them studies a different form of water. So Tindall, I say, studies ice, although of course he also studied water vapor. Piazzi Smith is, clouds. Dansgaard is ice. Stummel is the ocean. So I guess in that way, I was trying to generate a narrative history that that forces the reader, through reading it, to come to, feel the different approaches. And then hopefully when you get to the end, you see a little bit of the artificiality of this thing called climate science that we now kind of take for granted. I thought I might just, at the risk of, I might just share with this other slide that I had at this.
Sure. Yeah.
Just this, when I mentioned that climate scientists are also historians and are self-aware historians. I thought I would just share these two books by climate scientists about their own research. So these are autobiographical, partly accounts. I mean, Richard Alley's book is less autobiographical, but he was a player in a lot of this, which the titles of which directly kind of refer to the historical quality of the research that they do. We have A Time Machine and we have Frozen Annals. And then here, perhaps more tellingly or more deeply in a way, are two, well, one famous image and one perhaps to be famous image from different reports of the Intergovernmental Panel on Climate Change. The one on the bottom left is from the third assessment report and is also known as the hockey stick image, famously controversial image showing estimates for past temperature change. The gray is the error bars, and you can see the different kind of data that's being used. And then we have, well, these aren't showing future projections, as I mentioned. These are showing instrumental values versus values that are reconstructed using climatological techniques. But we can also add to these the scenarios that the IPCC uses, which project into the future and creates these, different pathways that we are understood to be potentially on, depending on policy choices that we make. So here are these images of time and change over time that look coherent, but are actually in some ways like Frankenstein-like things, putting together different kinds of, not just data, but different methods and techniques. So
yeah,
I just wanted to share those images because I think they're
I mean, they're fascinating because it's very hard to see in them the variety of kinds of research that goes into their own construction. It seems so, well, they're not neat graphs, but they give sort of an image of something that is actually extremely complex. And
their power comes precisely from their conciseness.
Yes,
and their singularity.
You can sort of see it sort of goes off.
And I mean, and Al Gore famously stood in front of the hockey stick thing and said, you can see it here. And of course, that was completely ineffective.
Yeah.
And it gets to this thing, which really is, what your conversations with this series is about, is how not only do we convey the content of climate science, but use our communications to impel action. And I certainly don't have the answer, but I think it's clear that presenting people with information is insufficient and in many ways can backfire.
So what do you think a book like Waters of the World, with the kind of particular quality it has in terms of writing and in terms of discipline as historiography of science, that it can contribute to climate science and to communication of it? Do you think it has sort of a specificity to the way that it to the way that it communicates this, or advantages, disadvantages that it holds?
Well, the fundamental thing I wanted to show is that, climate scientists are people. It's quite banal, but I think it gets to this question of the division between facts and values, or facts and emotions, which has come to dominate the way we talk about climate science, as if if we talk about facts, we can't talk about emotions, and if we talk about emotions, we can't talk about facts. And I guess I wanted to show that, you know, science is made by people. People are, you know, people are products of emotions and mind and bodies and all of these things together, and science is a product of that. And that's not something to lament or to try and cover up, or to do the science first and then tell it later. You know, that's the nature of science. And I feel like science is such a powerful and central feature of the world that we live in today, that if we don't represent that fully, we do a disservice. And I think the problem is that people have gotten quite defensive, understandably, because of the way science has been, and climate science in particular, but also we see it with the pandemic, has been politicized. And so there's I think an understandable desire to kind of buckle down, as it were, on rationality, on facts. And I don't see those things as being opposed. And for me, the form of the book and the content of the book was a way of showing that. And the biographical approach to me is just a natural thing, because once you're looking at someone's life, then it becomes obvious that the personal and the scientific can't be separated.
I mean, you might think that if you want to talk about efficiently communicating results of climate science, one might think that if you write a book where you report all the contingencies and the failures and haphazardness of the actual conduct of science, that would sort of erode confidence in the science that comes out of it.
But I think but
I don't think that's true.
No, I that's why I have a problem with the continuing emphasis in some quarters on the importance of consensus in climate science, because I think, as we've seen with the pandemic, what we need to do is to be much more open and much more engaging about the fact that science is based on self-critique, and that if we, and you know, we can see this in other areas on the far left and the far right, the loss of spaces where critical discourse can happen. And I think this emphasis on consensus in science is potentially a feature of the same thing, where in the name of doing the right thing, as it were, we risk alienating the public, who sees that actually science, you know, they can see, they have ways to see, even the people furthest away, that scientists don't always agree with each other. And that in itself is not only not a problem, that's the essence of science that we need to preserve. So I don't find that to be a compelling argument to batten down the hatches. But I think that it has characterized, and I think I'm sympathetic to climate scientists who've been in the front line in many respects, and I understand the impulse to want to double down on assertions of relative.
Yeah, I mean, I think so I have a particular interest in these questions of consensus, and then one of the things that I'm really struck by is that the way that the notion of scientific consensus works today is that it's an exclusion mechanism. And it's an exclusion mechanism which works where scientists sort of hunker down and say, we figured this out, you can't understand anything about it, but we all agree about it, so now you just have to acquiesce. And the thing is that acquiescence on the part of the public is not something that's ever going to happen. In order to get the public on board, and in particular, I mean, just to understand, but in particular to act upon it, there have to be some sort of inclusion of the public into the constitution of consensus itself. So the whole consensus mechanism has to be sort of broken up a little bit, so that they can sort of see so people can sort of look into the laboratory and see what's actually going on in there. And I think the historiography of science has really good potential for letting people doing that without necessarily compromising on truth and compromising on say what we could call something like epistemic responsibility or something like that, where you know any story can be told. Not any story can be told by the history of science, but you can tell a story about the constitution of this consensus that sees that sort of allow people to understand how this works. And also, you know, one of my favorite philosophers, Leibniz, said this already in the 17th century, said, okay, the way that you have to relate science is that you have to not just tell sort of how you demonstrated this, but tell what he called natural histories of science, which was basically stories about how scientists came to their discoveries. Because then, as he said, well, he said, this is an old Platonic theme. He would say, well, everybody become partners in discovery. And this notion of making the public a partner in discovery is something I think that maybe the historiography of science and something like a book like The Waters of the World is very efficient in doing, letting people have a peek inside the laboratory.
That's lovely how you put that, Mogens. I would say it's a big luxury to have such a long, you know, so many words. As a kind of former one-time journalist, I'm very aware that most people just read the headline and look at the pictures. So I'm not naive about how we scale things. And I think we just need to be very attentive to genre, which again is why I think it's the way that you're running these conversations is great, because it's about thinking creatively across a range of genres about how we can do things.
Yeah, so I think this. Thank you very much, Sarah. So I think it was good, and now we're at 47. So I think it's about time that we see a queue of people who want to ask questions. So I think a queue. So I think we will do that. And I think the first person was George Borg. So, and if you ask questions, please put your camera on. Yes, thank you.
Hi, thanks for taking my question and for this presentation. I'm a historian and philosopher of science at the Science History Institute in Philadelphia. And I'm interested in the historical sciences. I'm wondering if I have two questions, if I may. I have about climate science. The first is I'm wondering if you could elaborate a bit on the sense in which it's a mongrel science. After all, in listening to you talk, I could think of sort of other sciences like physics and chemistry that also treat a phenomena at very different spatial and temporal scales, with different arrays of theories. So I'd like to hear, if there's a specific sense in which climate science is mongrelly for you. And then my second question is, I'd like to know what made climate science a specifically historical science. I guess you said you don't like milestone science, but I'd like to ask anyway, what you thought were the key steps or whatever in making climate science a historical science. Thanks.
Thank you. I'm a Philly girl, so it's great to know that you're in Philly. So that's a good, those are great questions and a good prompt to clarify what I mean by mongrel science. I have to say it's not a phrase I've used before, but clearly it's one I should, it's catchy, isn't it? I don't know if I want it to be catchy or not. I guess I would say that I'm not a philosopher of science. So for me, it's a historical statement that historically climate science emerged as the product of different disciplines that came together in the 1960s and 70s as you get growing empirical evidence from paleoclimatology of a degree of dynamic change, kind of a natural background level of dynamic change in Earth's climate. And then you get the emergence of, the development of geophysical fluid dynamics, which gives techniques for establishing fundamental equations describing the motion of fluids. And then add to that the emergence of computers and computer modelers who can use those equations and that empirical data to generate new tools for either understanding or simulating climate. So that's just a very broad outline of how I would see it as mongrel, or just the basic elements, I guess, of what comes to be known as climate science. And a more specific instantiation of that is what comes to be called Earth system science, which in the early to mid 80s is something that emerges at places like NASA for various reasons. And there's a diagram, quite a famous diagram that I include in the book called the Bretherton diagram, which visually represents the multiple disciplines that go together to make up Earth system science. And the thing to say about that is that it's both describing what they think constitutes the planet, and it's also a map of the disciplinary landscape, right? So each discipline is a feature of the planet. How is it a historical science? Can you just say that again, what you...
Oh, well, what were the major steps? I appreciate what you said about milestone science, but in making it a historical science, I mean, was it always historically oriented?
Well, I mean, geology, it comes out of geology in the 19th century, right? Like the study of the Earth's past through, understanding sedimentation, and then you get, I mean, there's different, it's not an easy question to answer, and I don't mean to be weaselly about it, because there's different ways in which it becomes historical. And the way in which it becomes historical in the sense of a timeline is, emerging from geology, but then getting elaborated with incredible detail and longevity through these tools of, the mud cores, the tree rings, the ice cores, the stalactites, the stalagmites, all the amazing bits of paleoclimatology that start to emerge in the 1960s and late 50s, when you get isotopic chemistry that enables them to date things very accurately. But I would say that the modelers and the theoreticians, they're thinking about dynamics at the same time. And so that's also kind of, it's about time. I wouldn't say it's about history, but they're thinking about the climate as a system that's dynamically unstable at the same time. And so part of what happens is that they're trying to map these two ways of thinking about climate onto each other. Yeah, I'll leave it there. Thank you.
Thank you very much. I have another question from Pascal Marty.
Yes, thank you, and thank you for this very interesting discussion. It's a very broad question, but from for previous experiences, I have many times heard specialists of climate science complaining about how difficult it was to engage with humanities and social sciences, and at the same time, it was expressed like a regret, saying that they suppose or they think that there is a lot to be obtained with a sort of a joint effort from people in humanities, social sciences, and climate sciences. And however, there is sort of a divide still between earth science and the humanities. So do you think that instead of trying to explain science, it's better for establishing a contact to go through history of science and explaining how concretely science is made, what is the scientific work of people in climate science? Do you think that for engaging with the people and perhaps with convincing more about the emergency of climate, it's better to instead of stressing the results, just explaining what is this science about?
Okay, I think you started in one place and then you ended up somewhere that I didn't expect, because I thought you were going to say that history of science could be a bridge between climate scientists and academics in the humanities. But it sounds like where you ended up was saying maybe we should just try and communicate histories of science to the public and leave the climate scientists out of it.
Yeah, so excuse me, so I made sort of, I mixed two things because, well, perhaps I omitted to say that from what I understood from people in earth sciences, they very often expect that social scientists will be sort of, helping in communication. And perhaps that's not what we want to do. But yes, I think the two sides of things that sort of, well, one side would be the progress in science, and second would be the communication towards the public.
I mean, I'm biased, but I think history of science is a very natural bridge discipline between a lot of things. So within the academy, between climate scientists and other scholars in the humanities. I mean, as well as a way possibly to communicate the results of climate science, but there's an uneasy relationship between historians of science and scientists always, right? Because we tell the dirty laundry, and we don't tell the histories the way they tell the histories. And I have experienced this quite directly. I mean, I'm speaking at a conference I think finally in May, it's been much delayed, Royal Meteorological Society, and they're doing their own history conference, and I'm almost in there as an anomaly. I mean, they don't know really what to make of me. So I would say it's not easy, but that's an indication of how important history is to scientists. I think there are substantive collaborations now between earth scientists and some historians doing what's called big history or deep history, where they sort of use some of the tools and data of earth science to do different kinds of histories. That's not my field. I think it's interesting, but I think it's also potentially problematic in some ways if history becomes scientized in certain ways. And I don't mean simply by using scientific data, but captured by the idea that we can tell like the story, the one story finally. You know, I think that the proclivity that historians have for, you know, perspectivalism and contingency and those kinds of things doesn't translate easily to those collaborations, and that might be part of why there aren't more kinds of collaboration. So I would say it's a complicated and somewhat fraught issue, but just that I think it's generally we need to move beyond the idea that climate scientists should be the ones engaging, the only ones, as it were, that they have a special responsibility to engage with the public. It's too much to expect of them, and indeed they're not necessarily equipped for it.
So one of the things that came out of the last IPCC report is a long list of articles that engage with things like storytelling in the communication of climate science, and what has so I've read a whole bunch of those attempts at telling, okay, and also in IPCC reports there is a lot of storytelling going on. But I also very often think that it's kind of on the narrative level, let's say in the craft of telling stories, it's extremely primitive very often, and I think it's a pity. I think it also sometimes it sort of testifies to the fact that maybe scientists don't really know how to write histories. I mean, and they don't. It's not their job. So I think maybe there is some work for historians of science to do them, but of course it requires some sort of compromise between the two disciplines in the sense that the climate scientists, as you say, Sarah, may be a little bit suspicious about taking out the dirty laundry and having stories told about themselves.
Yeah, I don't think we should be aiming to have some discipline that does everything. I mean, and sometimes I think maybe that's, when the talk of interdisciplinarity, I think sometimes outpaces itself. Sometimes it's suited to the task at hand, and sometimes I think it's a bit of window dressing or flag waving. And in fact, what we really need is multiplicities of approaches, and we need to create the spaces in which those multiplicities can be seen as equal and distinct. And that was one of the things that came out of the latest IPCC report, was that the order in which the working groups are released, the physical science comes first, and then mitigation and adaptation later. And that there's a kind of epistemic prioritization there, and that maybe things like that need to be thought about more explicitly, so that we're balancing out different ways of understanding climate change, not just climate science, and recognizing that it's not, physical science first, social science later. We need to bring them all into conversation on more equal footing.
Okay, I think this is actually a very good note to end this conversation. There were a couple of comments in the comment boxes, but I will leave them as comments. So now we're at 6:01. So I just want to say thank you very, very much to Sarah for presenting this, for presenting here and talking to me about these issues. And then also, of course, thank you to all of you who were here and listening and asking questions. So thank you all, and hope to see you all for the next conversation.
Thank you so much.
Yeah.
Thank you.
Bye.